Okay, good morning. Any of you been here last year? No? Okay, some of you. Same weather, right? I was hoping, yesterday when I was coming, I was hoping that, okay, at least for the morning it will be shining or something like that, but no, not really. But it's shining above the clouds, exactly. Thank you everyone for coming. My name is Jacint. I'm a storage architect. I'm dealing with NetApp systems for about 10 years now. And I prepared this presentation for today. So it's this time I'm not going to make like a traditional product presentation. So I didn't come here like that, okay, this is our product, this is why it's good, and this is why you should buy it. It's a little bit different. So as we are pretty much 5-6 years into all-flash systems. All-flash systems became, let's say, normal on the market. So what I did was I collected together the critical features what an all-flash system should have in 2019, and we will go through these features, and hopefully we will discuss that what do you think about these features. So I will include product examples, obviously, because when I see that, okay, this should work like this or this should work like this, I will have a couple of examples so you can easily understand that, okay, what I'm thinking about. Please ask questions. So I know it's very early in the morning. I know it's raining. I know it's the first day, and I know that I don't speak Romanian, so it's maybe not very comfortable for you to ask me questions. But please do so if you don't understand anything, or if you have doubts about the things I'm speaking about, or if you have a different opinion, please discuss. So we have a good 45 minutes. I prepared enough content to speak for 45 minutes, obviously, but if we have a discussion, that's much better than if I'm standing here for 45 minutes and I'm telling you what I think about all-flash products in 2019, and you are either bored or don't agree with me, and then you leave like that, okay? So how many of you already have an all-flash system in the data center? Okay. Okay, so the number one, let's say, okay, I call all of these are critical features because an all-flash system is a little bit different than a traditional hybrid or a spinning drive based system. Obviously, maybe for you as a customer, not all of these features are critical. So maybe some of the 10 features I prepared together, you will say, number 5, okay, I don't care about this because this is not my use case. I consider all of these are critical because these are probably the minimum requirements what a system should have today. So number one critical feature of an all-flash system is obviously speed. So that was the very, very original focus of all-flash systems in when the whole story started, let's say in 2012, 2013, the very, very first all-flash systems on the market came out to solve speed problems. So some of the customers had issues with some of the applications. They were not fast enough. The issue that the applications were not fast enough was pointing back to storage, and then as Flash, as the new media was available, some of the companies started to make tests that, okay, what if we build a storage system which is only using Flash as a media, so how we can make things faster. Speed itself is extremely easy to deliver. So today, every single thing to be able to build an all-flash system is available on the market. So if you go to any, let's say, PC shop and you start to buy hardware pieces together to buy, let's say, at least a server type of computer, and you are putting SSDs inside to it, and then you install some sort of operating system, let's say a BSD or a Linux operating system, you will be able to create a storage-like drive or a storage-like device which can deliver the speed. Obviously, you need to figure out a lot of things what the storage vendors already figured out, but basically this is the easiest part. The speed requirements are obviously changing. So 5 years ago, it was more than enough if majority of the vendors said that, okay, we can do sub-millisecond of latency. The sub-millisecond changed after some time, and we started to speak about sub-half millisecond. And with the new type of capabilities and the new protocols and the new capabilities, basically the speed requirements are increasing, and the response times are going down. But the real question, do you really need that type of speed? So in majority of the cases when I have discussions with customers about investing into an all-flash storage, and they show us their existing performance delivered by their existing storage to their applications, are typically 1/10. Sometimes it's a very, very small performance compared to what they want to aim as a performance of an all-flash storage systems. So in a lot of cases, I see customers are asking for 500,000 IOPS for their new all-flash storage systems, and in reality, they're running 5,000, maybe 10,000 IOPS. So the application requirements will not change just because you are changing the architecture to an all-flash system. So you don't need to jump from 5, 10 to 15,000 IOPS up to 500,000. This whole environment is not going to change. Obviously, when you are planning, let's say 5 years, 7 years for a new storage system, you are trying to figure out the future. So the scaling is still important. So I will scale about the performance. So the big question here really is that, how much performance do I need? And I think this question is not any different than this question used to be in the past. So there are tools to be able to figure out this question very, very easily. And the real question is that how I add performance later. So that's the bigger. The second thing is capacity. You may see in this chart before if we had a discussion in the past any time, because I'm using this chart for 5 years now. So this chart is a previous IDC prediction for the end of 2017. So IDC was predicting 4 or 5 years ago that the price of the flash is going to drop to the level of disk by the end of 2017. So currently we are in 2019, so 2 years later, as what the prediction was telling, and still the price of flash is pretty much 2x compared to the price of generic spinning media, what you would use for application. So obviously, if the price of the media is 2 times more expensive than the price of the generic media you are coming from, then obviously the capacity is the main question you need to answer. So I put together a couple of things about the capacity considerations. Obviously, the easiest way to handle capacity is that I don't care about efficiencies. And I say that, okay, if I need 100 terabyte of capacity or 50 terabyte of capacity, I simply buy 50 terabytes of flash and I will be happy. The only issue with this method is that if you are thinking about spinning media with the same amount of capacity on flash, you are going to purchase the equipment for 2 times the amount of the money. If that's fine, that's also probably fine for the storage vendor you are buying from as well. If that's not fine, then this is the place where all of the storage efficiency technologies are coming in. So you can start to play with the duplication and compression and all of these capabilities, which are extremely critical today for any all-flash storage systems. Many vendors have different type of innovations in this space. So some of them are saying that, okay, we have so brilliant deduplication that you don't need compression. Some of them are saying our compression is so awesome that you don't need deduplication. These technologies work together. So some of your applications will work with deduplication very, very well. Some of your applications will work with compression really, really well. So in reality, you need both of them to save capacity. If you go back to the previous picture, the price difference today, as I mentioned, is 2x. So obviously what you want to achieve is that using storage efficiency to decrease the capacity you are buying by 50%, so you don't need to spend 2 times the money on the storage system. So that's the theory. In some of the discussions what I had with customers is that some of the vendors are suggesting customers that theme provisioning is an efficiency technology. It is not really. So theme provisioning is not going to make you store less capacity. It helps in a lot of ways, but basically theme provisioning itself will not help you to have decreased capacity to be able to store. So it's not going to save you any money. Not even 10 cents. So how you can verify all of these? So there are a lot of technology, and obviously there are a lot of vendors going to you and telling you that, okay, this is our technology, and I guarantee that it's going to work for you. So obviously the easiest way to figure out is to run a proof of concept, right? Because you own the data. The storage vendor probably have a demo equipment, so they can ship the demo equipment to you. You put the data on the equipment, and you can run your test. And if it works out for you, then it's good. You can buy that thing. If it doesn't work, then you can tell the vendor that, okay, you did this very nice presentation. You told me that this is how it works. I tried it in my own data center, and it doesn't work. So what to do now? The real question is that, do you have time for a proof of concept? So that's the main question. Proof of concept is typically starting from at least 2 weeks. In that 2 weeks, you need to dedicate at least an engineer who is able to deal with the topic at least a couple of hours a day. And then after 2 weeks, you manage to do a proof of concept with a single vendor. If you are doing things as most of the customers are doing, that probably you are at least speaking with 2, 3, maybe 4 vendors. So that means if you want to do proof of concept with every one of them, that means that's a good 6, 8 weeks of doing proof of concept with every single vendor, and then trying to analyzing the results and trying to match them together and so on. So that's a lot of time, and obviously that's a lot of time and engineering resources and figuring out if this is something for you. How many of you did proof of concept with any vendor in the past? How did it go? You was happy with the proof of concept, or it did go the way you wanted to?
NETAPP, so you have some expectation.
Yeah, and that's a very good point. So the point here is that there is an expectation with the proof of concept, and the thing is that the expectation from the customer and the expectation from the vendor is often different. So if you are doing a proof of concept as a customer, you have a list of things you want to figure out. And you want to understand by the end of the proof of concept. On the other hand, the vendor have expectations as well, because the vendor is investing the equipment and the people into this process as well. So the vendor is going to have a list of things what they want to show to you, which may end up with a little more time what you expected from that proof of concept. So proof of concept thing is extremely nice, but it definitely requires a lot of time. So if you are not weak on resources in terms of time, so if you have these resources, if you have the time available, if it's not like, okay, in 2 weeks I'm running out of capacity, so I have to purchase the equipment right now, that I would personally recommend to do proof of concept, because that's the easiest way to figure out if the equipment you are going to buy is going to fulfill your requirements, if it's really going to do what you want to achieve. The next thing on the capacity topic is the vendor guarantee. So every single vendor, maybe not all of them, but the majority of the vendors in this space are offering vendor guarantees. So vendor guarantee means that, let's say NETAPP as a vendor is telling you that, hey, you need 100 terabytes of capacity, and we will guarantee you that with the technologies in the system, we will ship you, let's say, 35 terabytes of capacity, and we will guarantee you that the system will be able to deliver 100 terabytes of capacity. This sounds good. Actually, this is a written guarantee between, let's say, the vendor and the end user. It has nothing to do with the partner. It has nothing to do with the distributor. So it's a very simple contract. There are issues with it, obviously. So as I mentioned, that you probably, as a customer, you are dealing with at least 2 or 3, 4, and so on vendors. So obviously, the vendor guarantees are different from vendor to vendor. So maybe some of the things are different for a guarantee coming from one vendor, and is going to be very, very different with other vendor. So obviously, maybe first time it sounds easier to do and accept the vendor guarantee and save time doing the proof of concept. But on the other hand, you need to spend a lot of time going through all of the contracts, what the vendors are offering, and checking all the fine prints. What happening is the vendor is not shipping and fail on the efficiencies. How the vendor is going to claim and reclaim and ship the missing capacities for me. What are the technologies are included in the guarantee, for example. Let's give you an idea. Some of the vendors in this space are requiring to have you to have snapshots in the capacity guarantee. The reason they are doing that is that obviously if you have, let's say, if you have a database which is 10 terabytes, if you take a snapshot of that 10 terabytes, it's already a 50% savings in most of the capacity guarantees. So that means that they fulfilled the requirement of to be able to shipping more capacity, what they are offering. It doesn't really solve your problem storing data. So maybe the vendor guarantee sounds good on the first, but it definitely not replacing the proof of concept. So if you're still considering between the vendor guarantee or the proof of concept will win every single time if you have the time for running it. And the last piece is the monitoring. So obviously, once you have the system, once you purchase something, and once you start to put the data on the system, you need to figure out what is the actual efficiency I'm aiming. So you need to have an up-to-date data every single minute to be able to figure out that, okay, that how much data I do have on the system and how much data it's eating up from the capacity I have, and most importantly, what is the capacity I still have. And the bonus would be that, okay, what is the time by then I'm going to run out of capacity. So obviously, as I managed and monitored many storage systems in the past, I would say that, okay, for me, it's a critical feature to have if the storage monitoring is telling me that, okay, you have about 300 days, and by that time you will run out of capacity, because I know exactly that how much time I have to acquire new capacity and run after, let's say, a salesperson or a local partner to deliver my extra capacity. Any question about capacity? Okay. Yes, sir.
How does the POC happen? Does NETAPP come with all the equipment in a box and put them, and then only discuss with the customer about what they need, and they have to transfer, or there are PMs involved?
It's typically so as NetApp is a channel-only organization, they don't really do anything by themselves. So in reality, the way it works is that typically at least the distributor or the channel partner is involved.
Yeah, I'm not saying NetApp.
Okay, yeah.
I'm asking if NetApp is providing the equipment already installed, or they are just sending boxes so that you lose time when
Yeah, so NetApp is basically just sending boxes, and the installation and the integration to the environment is done by the partner. So in this case, ETA2U or ITPS would ship the POC box on site. It would be a freshly installed with all the licenses or the software required, and then basically in most of the cases what we are doing is that we have like a pre-installation sheet about the networking details and how it would fit into the fiber chain infrastructure and so on. And once these details are basically available, then they can put the system into the SAN or the network infrastructure, and you can start to do the testing, start to move data, start to see the features and functions and so on.
Basically, you just bring the whole solution pre-installed
Yes.
to the customer and then integrate it in their
Yes.
environment.
Yes. Thank you for the question.
If you are doing a POC on network cluster, 2 weeks.
Yes. Although there are a lot of cases when you can do POCs on software-only solutions. So even Metro Cluster has a software-defined version of it. So you can run a Metro Cluster in 2 VMs. So for example, if you have a VMware infrastructure, it's quite easy to test these days. But if you go for a physical equipment with a Metro Cluster, then the installation time and the proof of concept can take a lot of time.
Testing storage efficiency, you can also do it.
You can actually.
On the SIM.
You need to have a little bit more resources than you would normally have, but you can actually test everything on the software version as well.
Okay.
So let's see, the next critical feature is handling media, obviously. So flash media is a completely different thing from how spinning media works. And this technical differentiation makes a big commercial difference. So basically what it means is that back in the old days when everybody was simply buying spinning drive-based storage, the spinning drive market and the spinning drive developments were very, very slow. So that means that if, let's say, any given point you purchased the storage system, you were pretty sure that 5 years later, if you wanted to expand that thing in capacity, you would be able to buy exactly the same type and same size of drives. So there's no issue with the capacity expansion. Typically in the old world, in the spinning drive world, a specific type of drive was available for 10, 15, maybe 20 years in a row, and you could just simply buy and expand the capacity without having any type of headaches. If you look at the flash-based media, in 5 years of the market, there are already 4 generations of different media, which some of them are somewhat compatible with each other. Some of them are completely different from the previous generations. So that means, first of all, that you cannot expect that when you are buying something today, capacity expansions of the same type of media with the same type of capacity will be available 3 years from now, because it just doesn't work that way. So first of all, you need to figure out that, okay, what is the capacity I need? Do I go for the capacity what I need now for, let's say, for the next 3 years, and after 3 years I figure out how I can expand this thing, or maybe buy something completely new, or I'm looking into architectures to figure out that how the future media is going in. But at this point, in a lot of cases, it requires, to look into a magic bulb and try to figure out the future, which is pretty hard even in technology. The other thing is that you will need to be able to mix different drive generations. So as I said, all of these things are changing extremely quickly. You need to have architectures where the new type of media will be supported with your current architecture, or the other option is that every single time when you are trying to add capacity expansions, you are simply buying a new device. Unfortunately, in the flash world, the changes are extremely fast compared to the changes used to be in the traditional media. And you also need to think about scaling capacity. So as I mentioned in the drive world, if you needed to go and you needed to add 20% growth, capacity growth in every single year, that was very, very easy. In a flash world, it's still easy for a couple of years, but after typically 3 or 4 years, the technology is so much changed that you need to figure out something else, maybe scaling out the cluster, maybe adding new type of shelves into your existing configuration. So there's a lot of technological headache. And also the support is extremely important. So the media, generally speaking, the flash media is reliable. So 5 years ago, majority of the storage analysts and technology analysts people said that, okay, the flash media is new. We don't really know how it works. We don't really know how it works over the time if you are writing a lot of information and so on. So it's extremely important to look into the support contract of the new flash equipment, how they handle the write information, how they handle the life cycle of the drives. To be able to have support 5 years, 7 years, maybe 8 years. How many of you are looking for 5 years support when you are buying a new storage system? More than 5, 7? Maybe 8? Oh, but the maximum I've seen new storage requirements was 10 years of support. So shipping a storage system and providing 10 years of support for that. I consider that a little bit crazy, but what I see extremely often is that starting out with a 5-year contract and then expanding it with another 2 years to finishing and summing up in a 7-year contract. So when you think about flash, you need to have a support contract with a vendor that's able to support the media for 7 years and replace the drive. For example, if the drive life cycle ends and the drive say that, okay, I cannot write anymore, that the support contract should cover that as well. And that's a very, very important detail. All right, next topic, encryption. So it seems that encryption is a growing interest in the flash world. Maybe it's just a timing thing. So as we are going forward in time, encryption becomes more important, and maybe it has nothing to do with the flash-based storages. But it seems that the encryption is going to be more and more important, and this interest is coming from application vendors. So I start to see more and more database admins and more application admins who are either asking for encryption capabilities on the storage system, or the worse direction is when they enable encryption on the application side without asking or without notifying anybody else in the organization. So why encryption is different in a flash-based storage compared to encryption in a spinning drive-based storage? In majority of the cases, when you think about encryption, you need to figure out that how my encryption is going to work together with my efficiencies. So two topics before we discuss that the efficiency has an impact on how much you pay for the storage system. So if you have well-working efficiencies in the storage system, that can save 2x or 3x the money you spend on a storage system. So obviously, if efficiency is breaking, that that technology, then efficiency will all of a sudden make everything extremely easy, extremely expensive very, very quickly. So let's say, again, you have a database admin who have 10 terabyte of database, which you think cost you 3 terabytes of storage, maybe 5 terabytes of storage. But if all of a sudden the database admin thinks that, okay, I need this encryption feature because I want to make sure that my database information is, because it's very sensitive, it's reliable, and if the DBA enables the encryption, then all of a sudden the cost of that DBA storing it is 2x, because it will have an effect on the efficiency technologies. So we need to make sure that we understand that how the infrastructure teams working together with application teams, and telling them that, okay, the encryption features are available on the storage, this is how we can use it, this is how we can manage the keys, this is how we can involve you in the process. And these people are not using application level encryption technologies or maybe host level encryption technologies, because that will make the solution extremely expensive. There are multiple type of features as well. Obviously, you can enable one of them, you can enable two of them, you can enable all the encryption features in the storage system if you have enough time to managing all of them. So the capabilities are typically there. Some of the vendors are working with self-encrypted drives, so the encryption is happening on the SSD level. Some of the vendors are working with the system-level encryption. There's no technology which would be better than the other, or obviously there are minor performance difference between them, but generally speaking, all of them works at some level. The main question obviously to ask is that if your organization is already working in a multi-tenant environment, so let's say you are isolating different departments, or you are working internally as a service provider and you are doing some sort of chargeback or payback on different organizations, then obviously you need to figure out how the key management can work between the different organizations, how I can give the key management to these organizations and things like that. But generally speaking, the encryption is manageable on the storage system quite easily. And I encourage everybody to just generically use it and advertise it in the organization that, yes, we have encryption. If the device is physically stolen, there's no way to restore the data, and so on. So scaling comes back, yes, sir.
Okay, you advise us to use, what if the system has not been designed to use encryption? What's the performance overhead on the storage when enabled?
So I see two things on storage system typically these days. One of them is using encrypted media. If you are using encrypted media, then basically there's a dedicated encryption chip on the SSD which is responsible for the encryption, so there's no performance overhead. The other option is the system-level encryption. The system-level encryption, in a first sight, sounds like a software encryption, so you would think that, okay, it probably has a bigger impact on the performance. In reality, what basically we are doing is that the CPUs, the Intel CPUs, have an encryption, a dedicated encryption chip. So basically, the encryption operation is offloaded to that dedicated chip. So there is a few percentage difference between the performance. It's like 3, maybe 5, thank you. 3, maybe 5% difference in terms of performance, but it's really negligible. In our case, what we are doing is that if the system hardware does not support encryption, then we will not support the encryption at all in that specific system. So we will not let you shoot you on the foot that you enable encryption and it will affect your performance. So the next topic is scaling. So as I mentioned, when you are when you are working with flash media is changing, but you still need to figure out that how you add capacity later. So from this point of view, scaling out the systems is extremely important. The other big change in this space is that how I scale with performance, because in the old world, there is a common expectation is that, let's say you buy a storage system today and 3 or 5 years later you expand it with capacity. And what we see is that majority of the customers expect that when I'm adding capacity, I will get more performance as well. So this is how it works. It's not documented, but this is pretty much the way we worked 20 years and 30 years with the spinning drive storage systems. With all-flash is different because on day one you get maximum performance of the storage system. So if you need more performance than that, you need to scale out the storage. So you need either upgrade the controller to a higher generation or adding more controller to that storage system. So that's, again, something you need to think additionally.
So you're saying that if I don't buy the full capacity on the HA cluster from day one, I add space later, then
There's no maximum. You are not adding more performance.
not what other colleagues of yours.
We need to discuss it later. You can find me at the booth and I will explain you why. But basically, an all-flash system day one will deliver the maximum performance what it can do. So if you add capacity later, you will not get more performance. You can scale the performance still, but that's you need to scale in a different way. Next topic is obviously data protection. So when you think about all-flash systems, you will think that, okay, when I'm upgrading my storage system to an all-flash, everything becomes faster, which is true. So your applications will run faster, your virtualization system will run faster, your databases will run faster, but it doesn't have any effect on your backup system. So if you need shorter backup windows and shorter restore windows, more importantly, then you will need to change the backup environment as well. You need to look into maybe snapshot integration, integration with backup vendors like Veeam, maybe Commvault, Symantec, you name it. So these are very, very important. In a lot of cases when we talk to customers and they did an all-flash upgrade, the only unhappy guy in the environment is the backup admin if the backup environment was not touched, because in that case everything stays exactly the same. And finally, disaster recovery. So disaster recovery is a huge topic. So in disaster recovery in an all-flash world, obviously, is not different. The only difference is that obviously, with the disaster recovery, you don't necessarily want to have an all-flash system as a DR. If you have all the money on the world, then obviously you can do that. Okay, I'm buying an all-flash for primary and I'm buying an all-flash for secondary, but that's going to take a lot of money and that they're going to have a lot of costs. So obviously, it's good to have a balanced thing when you say that, okay, on primary, I'm good with an all-flash because I need the performance for my applications. But on the secondary, I would like to have maybe a hybrid approach. Maybe if I'm ready for the cloud, I would want to, use DR. Maybe Microsoft Azure, maybe Amazon Web Services, maybe Google, whatever I'm comfortable with. But also there's a lot of additional technologies you want to think about. Maybe how the storage system supports cloning, so I don't need to stop my replication for the time of the DR testing. How can I do my DR testing? How often I can do my DR testing? Because the DR testing, the disaster recovery testing is the most important thing in this, from this aspect. you already mentioned Mentro cluster. It's also a good capability to have an active data center. So for some of the customers, a traditional DR is not enough, and they are more looking for active data centers when where one of the data center is down, the second data center is automatically taking over the configuration from the capacity and also the storage configuration as well. So these are also very, very important. So basically, this was the amount of information I wanted to discuss. If you have, a lady will come in roughly 30 seconds and will tell me that I don't have any more time to speak. So if you have any question, you can ask it now, or if it's a longer discussion, you can find me. We have a booth downstairs, roughly in the middle, and I will spend my full day there, so you can find me, and we can have a longer discussions with your questions or concerns if you have any. Thank you so much for coming. Thank you so much for listening to me, and especially thank you for any of you who ask questions. If you ask questions, then please come to our booth and tell anybody who is there that you ask questions on my presentation, so you will get something from them. And the same goes for this. So if you got this form and you are filling out with your data, then you can also take it back to our booth, and you will get something for it. Thank you so much for coming.